object distance from the objective distance is I have taken, that is u naught. Then where the image is formed here. So that distance what I can take? This is what here? Image distance only, right? What is the image distance for us? V naught only. So that image distance is V naught here. Then this image will work like an object for the second one. Clear? Now this distance is what I can say? UE, object distance for the eyepiece. This is the object distance for the objective lens. Clear? Now whenever you see this is UE here, for this lens the image will be formed somewhere here, that will be there like this. So that is H double dash I will take. Now this H double dash nothing but, don't worry about the images, the formations will be there like that only. So here this distance is what I can say? VE, very good. This is a H double dash. Image formed by the eyepiece lens. H dash is the image formed by the objective lens. And this H dash is working as what? Object for the eyepiece lens. Clear? Now whenever you consider this one, length of the tube, I said, what is the length of the tube? Nothing but I said, distance between the objective and then eyepiece. What is the distance between objective and eyepiece? What I can write from this? V naught plus UE. Clear? So that is V naught plus the magnitude of UE. That might be positive or negative. You have to take always V naught plus UE. That is a tube of the length of the tube we will take. Now in this, whenever you consider, object will be placed in front of the objective lens. At what distance? U naught distance. And for that image will be formed at what distance? V naught distance. The image distance for the objective lens. And also this image will work like an object for the eyepiece lens. So that distance is how much here? UE. And for this again image will be formed here. That distance will be how much here? VE. That is about the compound microscope mechanism mainly. Based on that we will calculate the magnifying power also. Before that, here length of the tube will be there. What is the length of the tube? Nothing but that is V naught plus UE. Just distance between the objective lens and then eyepiece lens. Clear? First of all write the notes. Compound microscope, combination of two lenses, known as objective lens and eyepiece lens. Known as objective lens and eyepiece lens. Known as objective lens and eyepiece lens. In the next line, objective lens will be smaller. Objective lens will be smaller and which is near to the object, and eyepiece lens will be larger and which is near to the eye, The next line, U naught is the object distance from the objective lens and it will forms an image at V naught in bracket image distance from the objective lens. This image will work like an object for the eyepiece lens comma, the object and image distances are UE and VE. The next line, capital L is the length of the tube. Capital L is the length of the tube. There is a distance between objective and eyepiece. Distance between objective and eyepiece. Copy that, we will calculate the magnifying power. Draw the diagram. Draw the diagram properly. Distances, you should write the distances properly here. Finished, huh? Now magnifying power will calculate. The magnifying power is nothing but just it is a multiplication of magnifying power of objective and then magnifying power of eyepiece. M0 and then ME. Total magnifying power of the compound microscope is magnifying power of the objective lens and eyepiece lens. Eyepiece lens nothing but whichever is placed just near the eye. That will work like a what? Simple microscope. In simple microscope, where we kept the lens? Near the eye only, right? So that this is a simple microscope. This is a normal lens. That is what you have to mainly identify. Here objective is just nothing but a normal lens only. But this will work like a simple microscope. Why? Because we have drawn in the second diagram of simple microscope, where the lens is kept just in front of the eye only. So this is a simple microscope and then this is a normal lens. Now M0 is nothing but what I said? Magnification of objective lens. Objective lens nothing but that is normal lens only. Normal lens nothing but what is the magnification? M0 is equals to V by U only, right? Image distance by object distance. Image distance for the objective lens is how much? V0. That is V0. So that is V0. And objective distance for the objective is how much here? Minus U0. That we will take in the magnitude only. Don't worry about that minus and plus and all. So the magnification is simply here, magnification M0 is equals to V0 by U0. Then for the case of eyepiece lens, I said eyepiece lens is nothing but what? Simple microscope here. For the simple microscope, we will have two types of magnifying powers. What is that? One is for the relaxed eye, another is for the strained eye. For the relaxed eye, what is the magnifying power? D by F. For the strained eye, that will be 1 plus D by F. So here we will take almost in all the cases we will take the relaxed eye only. So for the case of relaxed eye, generally the magnifying power of eyepiece lens, eyepiece is simply like a microscope only, simple microscope only. So in that microscope we will have the magnifying power, that is ME is equals to what I can say nothing but that is simply what is the main formula, that is D by U. So D by U nothing but here eyepiece I am talking about, so that D by UE will take. So So obviously minus d minus ue only, minus minus gets cancelled, there is no problem in that. So this is a magnifying power of eyepiece. In these two cases will be there. One is for the relaxed eye. Relaxed eye, where the image will be formed. Image will be formed at infinity. Very good. Then the magnifying power ME is equal to how much then? D by simply what will get here? F. F of which one here? Eyepiece. So only D by FE. Then for the case of strained eye nothing but you will get the image at what distance? Minus D distance. At minus D, or we can say it as 25 centimeters also in the numerical value. Then ME is equal to how much, tell me now? D by 1 plus D by FE only, no? You will get 1 plus D by FE. Those are the formulas whenever they have mentioned that is relaxed eye, otherwise strained eye. If they are not mentioning nothing but directly you have to take which value here? Relaxed eye only. So here simply this is D by UE and then this is V naught by V naught by U naught. So the total magnifying power of compound microscope is how much here? Total magnifying power is, I said, M naught and then ME. M naught value is how much here? V naught by U naught into ME value is how much here? D by UE. This is a magnifying power of the compound microscope. Clear? This might be changed just based on that relaxed, otherwise that is strained eye. If it is relaxed, it will be FE will get simply. If it is a strained eye, you will get into 1 plus D by FE you will get. Clear? Copy that. Magnifying power. Magnifying power of the compound microscope is the product of magnifying power of objective lens and eyepiece. Product of what I said? Product of magnifying power of objective and eyepiece lens. Is it correctly only? Yes. Copy everything. We will solve the problems, then we will start the astronomical telescope. ಏನೋದೈ ಹೆಂಗಿದ್ರು ನಂಬರ್ 1 ನಂಬರ್ 2 ಎಲ್ಲರೂ ಆರಾಮಿದ್ದೀರಾ? ನಿಮಗೆ ಕಣ್ಣು ಚೆನ್ನಾಗಿಲ್ಲಲ್ಲ, ಅವ್ರು ಏನು ಫೀಲ್ ಆಗಿಲ್ಲ? ದೇ ಆರ್ ಕ್ರೈಯಿಂಗ್. ನಿಮ್ಮ ಕಣ್ಣಲ್ಲಿ ನೀರು ಬಂದಿದೆ ಅಂದರೆ ಅವ್ರ ಕಣ್ಣಲ್ಲಿ ನೀರು ಬರುತ್ತೇನಾ? ಏನೋ ಯುವರಾಜ್ಗೆ ಏನೋ ಗೊತ್ತಾಗಿದೆ, ಏನೋ ಸೀಕ್ರೆಟ್ ಗೊತ್ತು ಯುವರಾಜ. ಏನಿಲ್ಲ, ಏನು ಮ್ಯಾಟ್ರು, ಏನೋ ಅಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಸೈನ್ಸ್ ಸಿಗ್ನಲ್ಸ್ ಎಲ್ಲ ಹೋಗ್ತಾ ಇದ್ವಿ. Finished? Write a problem then. A 20D, a 20 capital D. What is that? Power. A 20D, nothing but 20 diopter. Lens is used as a magnifier. A 20D lens is used as a magnifier where should be the object be placed? Where should where should be object be placed to obtain the maximum angular magnification. To obtain maximum angular magnification, in bracket capital D equals to 25 centimeters. Maximum magnification nothing but where the image should be formed. For the case of strained eye, there is relaxed eye, maximum magnifying power. Strained eye, correct. Strained eye nothing but where the image will be formed, capital D. That is the main important thing in that. Okay, maximum angular magnification nothing but the image should be formed at D. For the minimum magnifying power nothing but image will be formed at infinity, so that V is at infinity. Now in this case V is how much here? Minus D only, obviously 25 centimeters only, minus 25 centimeters. ಏನು ಯತೀಶ ನಿದ್ದೆ ಬರ್ತಾಯಿದ್ದ, ಏನೋ ಯೋಚನೆ ಮಾಡ್ತಾಯಿದ್ರು. You have to find out the object distance. How much you got? You have to get it as 4.17. You got that? 4.17. Yes, very good. 4.17 is the correct answer for that. Direct question only. Yes, 4.17. How many of you got that? Raise your hands. Yes, very good. Very less students. The remaining people might not be taking the sign conventions properly. See the question. At 20D lens. At 20D lens, nothing but what they have given here? Power. Power is equals to 20 diopter they are saying. Power is 20 diopter, nothing but focal length will be how much here? F is, P is equals to what is the formula? 1 by F in the case of lens. In the case of mirror, that will be minus 1 by F. So that 1 by 20 you will get how much it is? 5 centimeters, no? Correct? 5 centimeters only, na? So this will be in meters, obviously. In diopters they are saying. So that there is 1 by 20. If it is in centimeters, how much I have to take? 100 by 20. Power formula is what, ma? Power formula is P is equals to 1 by F in meters, P is equals to 100 by F in centimeters. Do you remember these forms? Yes, I have taken 1 by F, nothing but what I have taken here? Meters. Otherwise directly I will take it as centimeters only, 100 by 20. Then what is the answer you will get here? 5 centimeters is the focal length you will get. So F is equals to 1 by P or P is equals to 1 by F. Anything is same only. Then after that, what is the question? Where should be the object be placed? Nothing but what you have to find out here? Object distance U you have to find. Where should be the object is placed so that it is obtained a maximum angular magnification. When the maximum angular magnification will come? Magnifying power will be maximum when? In the case of strained eye, what is the formula you will get? MP is equals to 1 plus D by F you will get. So that is the maximum value. That is the maximum value, nothing but the eye should be strained. Whenever the eye is strained, then image distance is equals to what is it? V is equals to, simply you will use it as minus D. That is how much here? Minus 25 centimeters. That's it. Problem is finished already. So what is the lens formula? 1 by V minus 1 by U is equals to 1 by F. Then 1 by V value is minus 1 by 25. Then minus 1 by, obviously object distance is minus only here. That is equals to 1 by F. Focal length is how much here? 5. Then U is equals to how much you will get here? 4.17. 7 17 4.17 centimeters. Did you get the correct answer? Yes. Then next problem. The separation between the objective and the eyepiece of a compound microscope can be adjusted between 9.8 centimeters to 11.8 centimeters. 9.8 centimeters to 11.8 centimeters. Whenever they have given like this two limits, at that time you have to do at lower limit separately entire problem, and at higher limit you have to do entire problem separately. Okay, now that is about first one. You have to consider which value, that is 9.8. Then you do the problem as it is. Then you consider the 11.8, then you do the problem as it is. Okay, then full stop. If the focal length of the objective and eyepiece are 1 centimeters and 6 centimeters. 1 centimeters and 6 centimeters. Find the range of the magnifying power. Find the range of the magnifying power if the image is always needed at 24 centimeters from the eye. 24 centimeters from the eye. If the image is needed at 24 centimeters from the eye, nothing but you have to find out the magnifying power for the first limit. What is that? 9.8. Then again magnifying power for the 11.8. That is a range. That's it. Here they said 9.8 to 11.8. Like that only you will get the magnifying powers from so and so range to so and so range. Clear? That is about that problem. Very easy, only like normal magnifying power only you have to find. And also the image is formed at 24 centimeters, nothing but what they have given here? Strained eye. And also just you take the magnifying power formula normally only, and then you solve the problem. Then next problem. A compound microscope has a magnifying power of 100. A compound microscope has a magnifying power of 100 when the image is formed at infinity. Nothing but which eye that is? Relaxed eye. When the image is formed at infinity. Full stop. The objective has a focal length of 0.5 centimeters and tube length is plus or minus I said. Tube length is 6.5. Madam geno agide manege hogi bandidro ani ankonta idra. 6.5 centimeters. Tube length is nothing but what here? Capital L, right? That is 6.5 centimeters. Find the focal length of eyepiece. Find the focal length of eyepiece. You have to find the focal length of eyepiece here. Next one is astronomical telescope. Astronomical telescope. ಏನಮ್ಮ ಡೌಟು? ರಿಪೀಟ್ ಮಾಡಬೇಕಾ ಕ್ವಶನು? ಸಾಕಾ? ಹಾಂ, ಟೈಮ್ ಆಯ್ತಾ? ಯಾಕೆ ಆ ಥರ ಎಲ್ಲ ಅಲಿತಾ ಇದ್ರು? Hey, astronomy very easy re. Already that is related to this concept only. Again, tomorrow if I start nothing but I have to start from the origin again. Again I have to say compound microscope, simple microscope, everything. So just look at this telescope. It will be very easy only. But just opposite to the compound microscope. What is this lens here? Objective lens. But objective lens in the case of compound microscope is smaller or larger? Smaller. Now in this case that is larger. Then this is a eyepiece. Eyepiece is smaller, objective is larger. And also here it is the eye. Now the object will be placed near the objective lens only. So that object is placed here, that is H. Then where the image will be formed? Image will be formed somewhere here. And also when in the case of compound microscope, the object will be placed on at some distance. In the case of astronomical telescope nothing but where the object will be? Infinity. So that you have to take the object at infinite distance. Why? Because you are looking at the moon and then stars and then sun, everybody else. ಏನು ಉದಯ್ ಒಣ್ಣಾಲಿಯಲ್ಲಿ ಯಾರಿಗಾನ ನೋಡ್ತಾ ಇದ್ವಾ ನೀವು? At infinite distance our object is present. So whenever the object is at infinite distance, where the image will be formed? Focus. That's it. Finished. Everything is finished. What is this distance now? Focal length f of objective, f naught. So whenever the what is that, Ray? V naught will be equals to f naught only, no? Why? Because the object is placed at what distance? Infinity distance. You people only said that object is placed at infinity, nothing but where the image will be formed? Image will be formed at focus. I have written focus only. What's your problem then? I did not say, you only said that answer and I have written that. This is a H dash. Now this will work like a what? Object for which one? Eyepiece. Same story again. That is UE. Then after that where the image will be formed? Image will be formed somewhere here like this. So here like this, that is H double dash. So what is this distance then? VE distance. That's it. So here whenever the object is placed at near the lens, at that time that will be microscope, compound microscope. Whenever the object is placed at infinity, you are seeing the infinite distance objects only here, stars and then moon, everything. Means the object is at infinity distance. Whenever the object is at infinity, then image will be formed exactly at the focus. So only I have taken at the focus distance, that is how much here? F naught here. Then after that this image will work like an object for the eyepiece lens. So that distance is UE here, object distance UE. Then after that based on this object an image will be formed here, that is at what distance? VE distance. Now tell me what is the length of the tube here? L is equals to how much? F naught plus UE, plus or minus UE we will take. Okay, it's okay. It's okay, be relaxed. So that L is equals to F naught plus UE here. In this also again magnifying power will be there, same like the simple microscope only. Here this angle is alpha and then here this angle is beta. So that what alpha I can write? Alpha is equals to what? Alpha is equals to H dash by what is the distance here? F naught. And then what is the beta here? Beta is equals to, for the smaller triangle only you take that as H dash divided by UE we will take. So that UE is what here? Minus UE. Correct? And also this H dash is what here? Minus only. Why? Because it is inverted. Downwards it is there, so only minus H dash. However it will get cancelled only, there is no problem in that. But F naught is plus only. Why? Because here the object is placed at infinity, the positive direction is this one only. So my F naught is positive, UE is negative. Why? Because you are measuring in the opposite direction. Clear about the signs? Then magnifying power. Magnifying power is equals to what is the formula? Beta by alpha. In the case of simple microscope also the same only. So that beta by alpha nothing but the beta value is how much here? Minus h dash by ue, and then alpha is how much here? Minus h dash by f naught. H dash gets cancelled, and then this is minus ue. Then what is the answer here? F naught by minus ue. This is a magnifying power. Again this magnifying power will be there in two cases. One is about what? Relaxed and then strained eye. For the relaxed eye. Relaxed and then strained eye. So for the case of relaxed eye, what is the image distance? V is equals to infinity. I will send you, it's okay, please respond for this. V is equals to infinity. Strained eye, V is equals to minus D. Harsha, very good Harsha. So 1 by V is equals to 1 by V. Oh, you are missing Kishore sir. Yeah. 1 by V minus 1 by U is equals to what? 1 by Fu. That is 1 by Fu. 1 by infinity minus 1 by U. About the eyepiece only you have to consider always. This is the main lens for us. So only 1 by infinity minus 1 by minus UE is equals to 1 by FE. Then minus gets cancelled. This becomes how much? 0. Then UE is equals to FE. Then magnifying power. F naught by UE. What is the UE value? Minus FE. That's the answer. For which case? Relaxed eye. Then again 1 by V minus 1 by U is equals to 1 by Fu. So 1 by V, what is the 1 by V? Minus 1 by D minus of minus 1 by UE. That is equals to minus 1 by Fe. Minus gets cancelled. Bada missa. Okay, I understand. Then UE value is how much here? Fe D by Fe plus D. That is a UE. Now magnifying power is what? What is the magnifying power is how much here? F naught by UE. Yeah. UE value is Fe into D by Fe plus D. Is to yake appa fellow? F naught. 1 by UE value is how much here? 1 by UE is equals to how much I can write? 1 by Fe plus 1 by D. Correct? Directly we can write from here only. See that 1 by UE is equals to 1 by Fe plus 1 by D. Correct? Yes, instead of writing this and all, I am writing directly this one. So 1 by Fe plus 1 by D. That is a magnifying power. What ray fellow? En macha? Clear? Yes, astronomical telescope will use to look at the distant object here, so that object is placed at what distance? Infinite distance. Then whenever the object is placed at infinite distance, where the image will be formed? Image will be formed at focus. So only F naught I have taken. Listen, jokes apart. So length of the tube, nothing but what is that? What is the length of the tube? Arey macha. ಹೆಂಗೆ ಬಿದ್ದಿದೆ ದಯ ಬಂದಿದೆ So here length of the tube is nothing but the distance between the objective and then eyepiece. Here everything will be in reverse. Objective will be larger and then eyepiece will be the smaller. Not like this Rajeshwari, like this. Okay. So here alpha is nothing but visual angle from where? Objective lens, and then beta is the visual angle for the eyepiece lens. Magnifying power is beta by alpha only. That magnifying power is F naught by minus UE. Again two cases will be there for the relaxed eye and then strained eye. You already know the story here. V is infinity and then V is minus D. Just based on the substitution we will get the magnifying powers here. Clear? Copy that. J for the microscopes and then telescope.